Hi and welcome to Design Upgrade. I'm your host Saqib Aziz, and today we will look at a Grasshopper script that I actually prepared for my students at the UDK, so the University of Arts in Berlin. And this is basically a workflow that just generates a tower-like structure. And the main goal of the script is actually to slice that geometry and prepare it to extract a G code, which then can be, processed for a 3D printing method. And this is the basic workflow that we will look at. So first we will just generate the geometry in this section here. So what that means, if I just quickly show it to you, we will just generate this tower-like structure, right? Using some simple mechanisms in Grasshopper, just making sure that we get to know Grasshopper a bit better. And then we actually generate this loft that we are currently displaying. So this is the, let's say, column or tower-like structure that we want to process. Then what we will do is we will look at a simple slicing mechanism, so basically contouring the overall geometry, and then we are going to actually extract the points that we define ourselves, which will be the locations of the 3D printer and the respective G code that we want to actually generate. In a nutshell, that pretty much looks something like this. So we just will generate a bunch of points, right? Having some specific requirements, which the 3D printer might need. And then we generate a very simplified G code, so a string of coordinates that can be processed by a machine. And then we will do a slide exercise where we just custom illustrate what we are currently printing with a custom user interface. So basically just having something like this, and it just takes you through your geometry and shows how the print path actually will evolve and if you have any mistakes or not. So I hope you're ready and we can jump right into it with the first section, geometry generation. So before we actually get started, just a quick note that I am currently using Rhino 6, but this also works with Rhino 5 as a setup. And in Rhino itself, you want to change the unit size. So currently the units that I'm using are millimeters. You can see it here below. And the way to change this, if you're having a different unit setting right now, is you go here, you click with your right mouse button, select the unit settings. This will launch a pop-up window, and in this model units, we will change this now to millimeters, which we need for the 3D printer workflow. So just make sure that you have changed that. If this is the case, you're pretty much good to go. I am in perspective. You can, of course, change it using those clusters here, or you just go to your respective set view and choose perspective. Now you launch Grasshopper. In 6, you just press on this icon here, or in 5, you just type in Grasshopper, and this should launch your Grasshopper setting. Now we can actually start. And the way that we want to construct this tower, let me show it to you again, is we want to use simple curves that we then loft together. Basically, we will use 4 curves, which will be lofted together and just generate a generic tower-like structure. I've actually seen this form in another tutorial, so just want to say that here. But now we can actually dive into that. So I'm just going to leave my script up here, and we can now look at this blank, let's say, canvas and start to program. Let me just close this quickly. The first thing that we actually need is a polyline. Now you can find a polyline in curves, which is this section here. And in primitive, you can find some closed curve routines. One of them is the Polygon. Now we just select this guy, we put it onto our canvas, and this should be displayed now into your Rhino viewport also. If you're currently somewhere else or you don't even have your grid selected, just click on this component with your roller, mouse roller. You can get this icon bar, and then on the zoom icon, if you click on this, this will actually zoom to that respective object that you just generated. Now this component has 4 inputs and 2 outputs. Now let's look at the inputs. We have basically the base plane of this item, which currently is set to our origin in Rhino, which is 0, 0, 0, according to those axes X, Y, Z. Okay. Then we have the overall radius, the size of the current polygon. Right now it's 3 units. You can see it basically by these units. We have the segment count. So right now, as a default value, this is already set to 6. We can change that by having a slider, and a slider with a domain, you can just type in by 3 smaller than, let's say, 8. This is the way that you would write it, right? You put this on your canvas. I hook this guy up to my S, and you need minimum of 3 sides to actually generate a polygon. If you have 2, this will be a line and it's not a closed shape anymore. And then you can just switch between those polygons. Now we actually want to keep it to 6, so that's actually fine. And this here is actually a fillet radius mechanism, so you can just, for instance, hook up something like so, and this will fillet your geometry on the corners, hereby always calculating a radius. Now, if you have a higher radius, in this case, this will result in a circle-like shape, okay? But we will do a fillet afterwards, so currently we can just delete this guy, okay? Perfect. Now that we know the basics, let's actually give a number that makes sense in this case. So we are in millimeters right now, so we want to make sure that our, let's say, column or tower in this case has a good size. And right now we can just type in 300, which is like 30 centimeters if you want to, and not into the S input, but you want to put it in the hour radius. Now this will scale up my geometry. I have to zoom out a bit, and now I'm ready to go. The next thing I want to do is I want to not take this geometry to Loft, but I want to make it a bit more interesting. And the way that I want to do this is I want to take the line going like this, but then I want to here stop and go into the centroid of my geometry and make a connection to this point here. So I get rid of these 2 segments and actually do a new line that goes from this point to this point and this point to that point. The way that we can do this is that we actually explode this closed line. As you can see in the output, we have 1 line. And the way to do this is to use actually an explode component. So you can find it under your curve and then util, and it's the first icon there, explode. And we just hook up our P output into the curve. This will now generate your line segments and your vertices. Now that we have done that, that's perfect. Now what we get as an output, when we hover over the S output, you can see we have 6 line-like curve segments. And we can display that by having a list item. So just having a list item, I plug in my S there. And if I hide this, so I just select those guys and press the shortcut Control Q, this hides everything. And now you can see I have just 1 selected. So this item select just takes the whole list that you give it, and by its index, which is here, it will filter that curve. Now the index, if I just press in something like 0, smaller than 5, in this case, this should now let me filter through my live curve segments, my curve segments that I have there, okay? Now that we have understood that, we don't actually need this right now. We just wanted to visualize that. The one thing that I want to do now is I want to filter the first 4, and those 2 I want to get rid of. Actually, I don't need them, right? The way to do this, there are many ways to do this, but we want to use a split list mechanism. So we're just going to write a split list, like so. And if you hook up your list here, you get an A output and a B output. And this just basically works with, if you hover over here, it's telling you that the E input is missing. That means that you have to tell at which index the splitting of the list will start, basically. So we can test that, just get another slider, 0 smaller than 5. That's the range that we have, right? So it starts with 0, 1, 2, 3, 4, 5, 6 numbers. We get this guy here, hook it up, and then we can put a panel. Now we can just type in panel. And if you just hook it up to A, you can see that currently we have nothing. And then if I scroll up, you can see now it actually has 1 line in it. And then as we go along at 4, we actually have the first 4 lines filtered. Now this is a way that you could do it, or you can also just hook up a panel again and just write the index if you're quite sure which one that is. So basically something like this would be the case. So both ways work. Let's take a slider because it's a bit more illustrative. And now I can again Control Q, hide my geometry that's in here. I delete this and I get a container. Now I want to have a curve container. And a container is basically just a component that takes in information. This is a container and is always recognizable by a black hexagon with an icon in it. And this component doesn't really do a lot. It just takes in information basically. So we feed whatever is in 8. And as you can see already, if I highlight this, you can see that I have my 4 lines here. Now that's perfect. That means I can even take this list item and Control Q it, which means I disable it. Again, if you don't want to use a shortcut, you can also, if you have this selected, press your mouse roller and hit this blindfolded guy. This will basically disable the preview of this item. Now we are actually good to go. What we want to do is actually find out the centroid of this curve. Now, if you remember, what we wanted to do is basically get this point and then make a new line that actually goes like this. To do that, it's quite simple. We get an area component, this one, right? We hook up the initial curve that we started from, which will give us our centroid pretty much in the origin of our Rhino canvas, because this is something that we didn't define here at the P location. So the P location is taking to the origin. So in this case, the centroid is in the origin, but that is fine for us. And now we can actually proceed to close this polyline. Excellent. So let's continue on. Now, what we could do basically is to close this curve, because currently we just have 4 segments and we just want to extract the endpoints of this closed curve. So let us just do that. We can just type in join as a component, join curves, that is, right? You get this into your canvas. You can find it again under curve, util, and there's a second icon there. And then you just put in your curves that come from your container. Now, if you look in the C input, you have 4 individual curve segments, and the output will now be one polyline, open polyline, that is, but that's fine. Now, what we could do is again, Control Q this guy. And it's always good to just have everything displayed that you're currently working with. Otherwise, if everything would be on, you would be kind of lost what you are currently actually looking at, right? So that's why I always hide whatever is upstream that I don't need to see right now. Okay, now the component that we want to use here is called endpoints. It's a very handy component. So endpoints, I plug this guy in, endpoints, and this basically gives you the endpoint. So it's starting here, the start point and the end point. We can visualize that. If you're not sure what is the start and end point, you just take a point container, just type in point, this guy, and just hook up one of those points. And if you highlight that, it's green, so you know, okay, this is my start point, and actually this guy then is my end point. Brilliant. Now we just want to make sure how we actually close this curve. Now we know that this is the end and we know that this is the start. So the curve currently is going in this direction. Then why don't we just use this direction and then close it in this fashion, right? So we want to start with the end curve and put it to the centroid. And we do this by having a line component, which looks like this. And we feed in the end point into the A, and then the C, which is the centroid, this point here, into the B. This makes the first connection, very simplified, and we can just basically copy and paste the same component. Now what we want to do is start from this point and finish with this point here. So we take the C input in A, and this time my S will go into B. And now we have basically our closed line. Now we can bring everything together, join it again, and then we have one closed polyline, which we will do now by taking again a join mechanism of join curves, right? We feed in maybe the first curve, which is this here, the joint one, into the C input. And now we want to actually put in our 2 other lines. So we can start with this line here, this guy. And if I feed into this, something interesting will happen. If you're new in Grasshopper, you might have this problem always that if you make a connection, you can't really make them together or a joint connection, but you will just detach the other one. Now, the easy way to get rid of this is basically you just press the shift button, right? And if you see it here, it's very small, but you can see that there's a plus sign now if I hover on this input, and this will actually now make a joint input. So I can actually have more than one input going into the input C. And again, this is what I'm going to do, shift, press and hold, and make that. So I have now actually 3 informations passing through this component. And if I, again, select everything, hide it, Control Q, I have now my final resulting closed polyline. Perfect. Now the next step that we want to do is we want to take this line and actually make 4 copies of this, and hereby allowing it to actually do a loft. Now that might be too abstract to actually visualize that. I'm going to use my reference here. Now we take that curve that we had done, that we constructed here, and just making 4 copies, which then more or less will be just lofted together, which you can see here. Okay, so let's see how we can do that. Now, the first thing that we can actually have a look here is to bring in one last design feature, which is to actually fillet this curve. Now, we could have done it here, if you remember, but then we would have more than 6 segments resulting here. So just to make it easier, we do it now here. And there's actually a component called fillet. So we just use this fillet. There are different ones, but we want to take the normal fillet. And we just hook up our curve. And then we need to supply a radius factor. Now we can just type in something like 5, hook it up, and see if we are visually satisfied with that. And we can already see that this kind of could be, scaled up a bit. So the way to do this, if you have your slider now set to 10 as a maximum, I double click on the radius and I can actually scroll up the max bound here and just maximize our range. For instance, let's make it to 100 just to be on the safe side. And we can maybe just adjust the radius a bit more to, let's say 60. And now I want to disable the preview of my joint curve. Now we want to actually move those geometries up in the z-axis, which kind of looks like this. So we just want to make some copies, and then the upper ones you want to actually rotate or mirror. So there are 2 different ways. I actually had here a mirror technique, but I want to show you a more simpler one, which is just actually rotating those curves. The one thing we need to do is we need to move this curve up. So there's in Grasshopper, there's no way to copy it up. You have to move geometry up. The interesting thing is that in this translation vector, where you actually move geometry up, basically the translation defines the 3 coordinate system vectors, so the x, y, and z vector. You can just define it with a translation vector. And here we also have the control of, let's say, define it by the z unit. This is the unit that we need. There's also a y unit and a x unit. You just type in, for instance, x, and you will get the unit x, which is just a translation vector saying in the direction x, just have a unit 1 vector. Now we hook this up to our t input, right? And now we need values to supply to identify how high this tower is. To do that, we will use a range. Now we just type in a range. There's this component. And a range needs a domain. Now in this domain, we can define how high our tower is going to be. So a domain actually needs 2 values, something where it starts and an end value. We want to start with 0, so we can just leave the 0 as it is. And if you just apply 1 number, it will identify that number as the max. Now we can then just define our maximum height, which is 3 meters, so 3000. We hook this up in the D. Now we have to define the domain from 0 to 300. And in this domain from 0 to 300, we want to have a number of steps, and that will give us a numeric list back, which is from 0 to 3000, dividing that numeric list into segments. Now we don't need 10. If I hook up this panel into R, we actually want to generate 4 curves. So to do that, we want to supply here a number that generates 4 curves. So again, let's type in 4. For instance, because that's what you would think. You supply this in, and now you've reduced the steps, which is basically the number of items in that range. And you can see that we have 5 values here. Now this is because the 0, 1 is also taken into account, and from that it will generate 4 more values. So 0, 750, etc. Now we can just slide 1 back and to go to 3, and then we will have basically our 4 movement vectors. So we can just take this and put it into our F, into the units, and now we have generated 4 curves, just stepping by a value of, let's say, 100, which is a meter, starting by 0. Now the last thing we want to do is, because we already have seen the split component, we can again bring in the split list. We put in our 4 curves, these guys. I want to split it at, these 2 should go into A and these should go into B. And the way to do that is just we bring in a slider and just press 2 just to check out. We hover over 1 and we see, okay, at index 2, if we do that, it actually does exactly that. So this, I can control Q. And now I bring in a curve container just to evaluate that here. hook it up, and if I hook this up, I can see that these two actually go in A and these two go in B, which is precisely what I kind of wanted. So now I just want to rotate those which are in B, right? The way to do that is just to have a rotate, this component, rotate. You just put in the values in B into your G value, and you can see that this already has rotated your curves there. Now what we can do is we can bring all together and basically loft it together. Now we just again bring a loft component here. We supply or start with our A values. We bring that here. You can see this is already working. And now if you put in that with the shift button pressed and hold, we will now generate our loft there. Okay, so if I hide this here, I can now see that this is actually the way that I wanted this to be. Now we have a very interesting twist now, currently, right? And the way that it's twisting is a bit, let's say, too extreme. So we want to align the 4 curves that we actually generate here, right? The way to do that is quite simple. We bring in our loft options. So there's a loft options. So if you type in loft options, this is the component we want right now. We just bring it in. And as you can see, it perfectly fits in with the option input of my main loft option. This is here. So you just put it here. Now these are just some more, let's say, controls for the loft that you generate. You can actually close the loft. So if you just had a Boolean toggle, so you just type in Boolean toggle, which is this. It's basically just a switch of 0 to 1 or yes, no. So if I hook this up to my close and I press close, yes, it will actually try to loop back and close this loft, as you can see. You generate there a very interesting shape that in this potential case might even be kind of working, but it actually combines this curve back with this and closes it, and you can see that you have this here done. Now we don't want to do that, so just press false, right? And there's a adjust seams, which we also want to control. So just copy paste the toggle here, put it into adjust and hit true. And if this, your shape looks like this now, this is exactly what we want to do. So just make sure that this shape looks like this. In Rhino 5 and 6, I have noticed that there are some slight differences. So in Rhino 5, you might even not need to adjust them, right? Just try it out. And it, in the end, should look something like this. So just let me know if you have any problems with this in the comments. Now that we have actually reached this point, I just want to bring in one little design feature also. This is the last thing that we will do here, just to introduce you this idea of a gene pool, which is a slider kind of type, which is this guy here. And we want to use this gene pool to actually scale our curves that we have generated and hereby maybe create a bit more of an interesting shape, right? So I'm just going to currently, what my loft is, you can just hide that, Control Q. And to do so, what we want to do is extract those curves from the split one and the rotate one. So I'm going to use a list item and hook up my A input and zoom in and press this plus. And now I have the first curve, this guy, and in +1, I have this one. Now the same thing I can do with this output, and I will have my I, which will be this here, and my +1 is this here. Now what we want to do is actually bring them together and scale them. Now to do this, we need a scale component. This here, not the NU, but the normal scale, right? And this works in a certain way that you supply the geometry. You need to supply a center point from where the individual geometries will be scaled, and you need factors to scale that. It's basically the factor how much it's scaled. So if I hook up this curve here, for instance, it will be scaled half the factor of the overall curve, right? So to do this, we just need to supply those three or feed those three inputs. And the one thing that I want to put in here is the gene pool, this guy. So basically what this is a gathering of sliders. So you don't have to, do 4 individual sliders like this, but you can actually have it in one more or less interface. So you double click on this, and then you just define how many counts you want to have. In this case, I just want to have 4. You just press OK. The decimal point is, in this case, we can just leave it to 0. We don't need that. And the maximum we want to go is actually 1. Now this is the factor 1, which is just leave the geometry as it is, don't scale it. So it's 1 to 1. So I press OK. And actually we want to do the decimal to bring it also to 1. Now that was quite a mistake, so just do that like so. And we can just move them now all to 1. And now we need to do one last thing. We need to bring those individual outputs into one container. So we just use a merge. That is actually just merge a bunch of data streams, as it already says. So we can just hook up our curves just to be on a bit more, so just to have a bit more control. So I'm just ordering the curves the way that I want them to be, right? So I can just hide them, Control Q. And now I just hook up this into my G. And as you can see, it will already be scaled. But currently the problem is that everything is scaled to this point because my C input is the origin right now. I need to surpass that by having an area and an area hooked up to my individual curves. So now I always have the centroid of each of those curves, and this is where I want them to be scaled at. As you can see, this works quite nicely. I will hide this here, and now everything is actually scaled to, let's say, half of the size this actually should be. So if I hook up now my gene pool into the scaling factor, and I know this can be a bit of a hustle to understand, but we are nearly there, we can see that this actually works exactly how we want. And now we can actually try to, shrink our individual curves the way that we want that to be, right? So this is basically a design feature. Now we can all put everything just in our loft, and we can enable the loft. This should still work quite nicely. And now the nice thing is you can more or less shape your geometry the way that you want. So if you want to make it a bit more slim in the top part, so you can do it like this. If this is the way that you want to go, let's just maybe keep it like that. You can also do something else. This is up to you. Now we are kind of finished with our modularization of our geometry. Okay, so now once that we have done this geometry, we can actually have a custom preview. So we want to display it in another color because this red is not really understandable for this geometry right now. So I do a custom preview like so. This is a custom preview component, and I hook up my G into my the L into my G. I can hide that now, and you will get this hot pink as a default color. And it's literally called hot pink. It's not even something that I'm like saying to you right now. And if I want to change the color, I can use either a swatch, which is a common way to do that, right? So a swatch is just a color picker. You just click once and you can then literally decide which color you want to take with the hue saturation value, or you can also change into RGB mode. But I'll actually work with the hue saturation because it's a bit more intuitive for me to just cherry pick whatever color this should be. So for instance, like this, and I have now defined my tower here. I can also press on this and adjust alpha, or basically just controlling the transparency here. So let's make it a bit more transparent, and we can see now this is actually kind of working in a nice way.